Hello, in this presentation we will give a brief overview of the DragonFly project, an ongoing research project that has been developed in the Smart Cities Research Center of Instituto Politécnico de Tomar. The DragonFly aims to implement a mobile robotic framework for surface water quality monitoring. Let's start with motivation. In recent years, there has been increasing awareness of preservation, protection, and sustainable use of natural resources. Water resources, being one of the most important natural resources, face major threats due to contamination by pollutants of various types and origins. Maintaining the quality of water resources requires more robust, reliable, and more frequent monitoring than traditional techniques of data collection based on sporadic, discontinuous, and manual processes. The management of large geographical areas, the insufficient spatio-temporal discretization of samples collected by traditional processes, and the unpredictability of natural phenomena require a new approach to data collection procedures. So, naturally, these and related problems are addressed by the Ci2 Research Center in the thematic area of the Sustainable Resource Management. The aim of the DragonFly project is to implement enabling technologies for the deployment and management of a cost-effective mobile remote sensing framework, or cyber-physical system, for monitoring freshwater quality towards water reservoirs protection against pollution. The model is composed of several subsystems optimized for the collection of relevant water quality data and its transmission in real time to a central monitoring and control unit. The data will make it possible to identify sources of contamination and its evolution, being therefore a decision-making tool to trigger environmental protection mechanisms and lead to a rapid identification of the origins of the problems and their respective resolution. The first contribution of this project is the implementation of an autonomous and robotic mobile platform for acquiring data in the form of spatio-temporal measurements and dispersion map of chemical concentrations on the quality of water in rivers, reservoirs, and estuaries. The second is the implementation of a full-scale monitoring network based in IoT, allowing a continuous analysis of water quality and to determine the scale and origin of pollution sources. The system also provides a built-in early warning communication service able to alert the monitoring authorities or the community in the presence of abnormal episodes. In this context, the results will enable the development of real-time monitoring systems to allow freshwater resources protection, meeting the United Nations Sustainable Development Goals and the European policy requirements on water. Our project is divided in 6 activities. The first is the design and implementation of an autonomous and robotic mobile prototype for water quality monitoring, the base station, followed by the respective field tests and fine-tuning. The third activity is the implementation and test of the IoT platform, evaluating the performance of data transmission, data storage, data processing, and data visualization and analysis. The fourth activity is the design and implementation of a web platform for an alert communication service. The fifth activity is to develop the search unit, an autonomous research unit model based on aerial or aquatic drone. Finally, the last activity is the development of algorithms or navigation strategies oriented to a collaborative network of robots to locate sources of pollution in water courses. A master's thesis integrated in the DragonFly project is under development. The research team is made up of several researchers from Ci2 of the Instituto Politécnico de Tomar and a master's student. In this project, we have the collaboration of the CIMT, Intermunicipal Community of the Middle Tagus. And finally, we want to thank to the National Programme of Scientific Research, FCT, which supported this project. Thank you.